Hey, my name is Teresa Ryan. I'm a associate professor at East Carolina University, and I'm really excited at the possibility of adding an ASA intern student to our summer research program. The project itself uh, has been funded by the Office of Naval Research for a number of years. It's a collaborative project between myself here at ECU, my colleague here, Jeff Feller, and a couple of professors at the Catholic University of America in DC. And what we've been looking at is how weather and terrain and all these different factors influence long-range acoustic transmission loss. And so this is Navy funded, so the Navy is mostly interested in how boats make noise, but it's really true for anything that could be making noise offshore, wind farms, and the like. But if you've got some sort of acoustic source offshore and you've got an observer onshore, what plays into whether or not the observer on shore can hear that. And it turns out that it's a whole lot of different stuff. Wind speed and direction is kind of the primary influence, but also humidity. The temperature profile plays in heavily. The sea state, how much the waves are cranking up. Shore topography, what is it urban? Is it full of trees? And then this parameter, the acoustic surface impedance. And that one is how the sound interacts with the stuff that is at shore. So the ECU portion of the work is really the experimental aspect of it. The folks from Catholic University are primarily involved in the numerical modeling, and the ECU team goes out and collects both the acoustic. We have a long-range acoustic device. Here you see it out on the pontoon that we have. And then we have a whole heap of meteorological measurement devices, anemometers, temperature sensors, and a 3D scanning LiDAR that gives us a really high resolution picture of what the wind is doing. And then we've got these microphone arrays that we can place strategically at shore or a little bit back from shore so that we are making the noise out on the boat, very controlled noise, and we're measuring the transmission loss with our microphone arrays and measuring the weather parameters at the same time. And so the program students will learn how to put all of this stuff together and handle the data and do some of the post-processing of the data. And then the ASA intern also has the opportunity to do a smaller independent project. We have instrumented UAVs that we can gather temperature profile data. We have the gear to measure acoustic surface impedance, and a past project was measuring the moisture content of sandy soil and looking at how surface impedance changed with moisture, near surface temperature with these little loggers, looking at how the different surfaces and being on the boat or over the water changes the first few meters of temperature profile, machine learning to figure out cloud cover percentage because that plays into wind speed profile predictions. So lots and lots of smaller research questions that we have all this experimental gear to be able to design something of interest to look into. And this is, we have a lot of fun. It's definitely challenging at times because it's outdoor work in North Carolina during the summer, but it's at the beach, and we take advantage of that with some educational excursions from time to time, particularly when the weather's not so conducive to data collection. So we work hard, but we play hard. And I hope that gives you a bit of an idea of the overall opportunity at the ECU Outer Banks campus. And please come join us out at the beach. Thanks.